Let's have a word about the outcome if batteries are not well produced and they show a thermal runaway. So I think I don't have to go in too much detail. That will happen if we see a thermal runaway. Of course, we have a great release of flammable gases coming out of the chemicals inside, and these flammable gases intend to explode if they are in such a concentration that they have explosive mixtures, and if they are in a confined space. And of course, this concentration will increase in the case that you have multiple of destroyed cells, which is an effect of the thermal runaway. So not going too much into detail, you can imagine if you have a container installation, for example, and you start this thermal runaway, you get a certain release of gases and explosive mixtures, and the result is seen many times around the world. So such container solutions had a big malfunction, big explosions, destroying the structure and rupturing by pressure. So these quite weak pressure-resistant housings are dangerous for people walking around or being around. And for that reason, we look for a solution to release the pressure, which will occur significantly after a deflagration. And for that reason, so-called explosion vents will be installed on the housing of such storage systems, and they will release the pressure to the outside in a safe way. So we have developed different concepts to size these so-called explosion vents on top, for example, on such container solutions. And we are supported by explosion standards which are available at the moment, because we are facing nothing else than a so-called gas explosion. And the systematic is called gas explosion venting. And so several surroundings, several setups can be considered. Therefore, different results will occur, which means you have installed more explosion vents or less. In some cases, these also need to be installed on the side because you're stacking these containers one over the other. And for that reason, you have a so-called side venting. So what is the option, or what is the physics behind it? If we follow the UL 9540A, we have to analyze what is coming out of a cell because of its chemistry. When we know the explosive gas air mixtures, we can do the sizing for these explosion vents according other standards like NFPA 60H, which has a lot of equations behind to size it. On the other way, of course, we go the road down and do explosion prevention. So if we measuring an uncomfortable amount of gases, we can switch down cool systems and try to prevent that more gases are evaporated. But this is prevention, and this is constructive explosion protection. So what is now the findings that we saw during many tests that we have done on such systems? I have a short video. Of course, it's time consuming, but it explains quite a lot.
Explosion protection. Today, we're bringing this expertise to battery energy storage. 3 product series uniquely engineered for modern BESS applications. The BESS core venting series sets the foundation.
So that's a standard solution for outside application, just venting the container.
To match your best design. Experience breakthrough innovation with our BESS Smart Venting series. The integrated Targo vent principle safely redirects the force of explosions upward.
So now we direct the explosion to the sky for people walking around avoiding injuries.
Meeting the needs of space-efficient, stacked BESS installations. Rimby presents the Best Premium Venting Series with Best Q Vent. This advanced flameless technology eliminates external flames while minimizing pressure and temperature effects, making indoor installations safer than ever before. Partner with Rimby, advancing best safety together.
Okay. So you see here different solutions, which I can explain later on in the discussion. So you need different technologies. So if you see here what is coming out of a container during the explosion venting process, you see a quite long flame duration, even if this is an explosion. And of course, this is not possible doing inside a building. And for that reason, we have a so-called flame arrestor element, which is installed underneath the explosion vent. And then the explosion will be quenched and you see no flame coming out. And even in the nearer surrounding, no dangerous effects happen. So that's our solution. And I just jumped through it. So we have 4 steps: analyzing the chemistry.
Time is over.
Yeah, doing the study, doing the calculation for the vent, and install it. So, and that's all.
Okay, that was quick.
Yeah.
Perfect. Yes. I knew he informed me that he had 19 slides. So
yeah. So I jumped through, and so maybe I could
shorten
shorten it in the discussion then a little bit.
Yes. And yeah, we are almost reached our 1-hour goal for this event, but I think a quick question to Roland is still possible. Maybe from my side, just really quickly, how often will this venting be needed? Do you have some numbers on that?
So we see about 8 to 10 events per year where really strong thermal runaways happen. You can see this on different platforms all around the world. And if you do not proper venting, you destroy the unit, and this lead to very long downtimes for the entire energy storing systems. So it's not seldom, it's regular, I would call it.
10 events counted for how many battery storage systems?
All around the world, it's a lot. So it's not that it's done every time or around the corner, but when it happens, it has a very strong impact on the large field installations.
Yeah. So we